Hello everyone, Norman here with McWane Science Center and welcome to Sci Sparks. If I told you that I could knock that cup over with one powerful breath of air, would you believe me? Yeah, of course not. But with this, it's a knockout. But what's going on in here? Let's find out. Normally, when we blow air out, it comes out all haphazardly. This is great for getting the air molecules moving, but not so great for long distance motion. See, air molecules experience air resistance and friction themselves, so they can't get very far moving randomly. But to see why this device does the trick, we'll need to introduce a new fluid to help us visualize what's really going on inside. By adding smoke, we've given the air cannon here a fluid that we can easily see as it moves. And when we release air from the cannon, we can see a ring shape form. This ring, also known as a toroidal vortex, is a much more stable shape. But it also has another feature. It's literally rolling through the air. When the vortex comes out, the ring shape is rotating, not on its side, but more like a donut being turned inside out. This rolling gives it a lot less resistance when it moves through the air, kind of like how a ball rolling has less resistance than if you slide it. This rolling happens because the air, or smoke, inside the toroidal vortex cannon is being forced out through this essentially perfect hole. The puff of air initially forms a ball that gets squashed by the air in front of it, while the air molecules along the edge of the hole get slowed down even more by the resistance from the solid material. Meanwhile, the air closest to the center is pushed out rapidly, getting our rolling started and creating the vortex. As the air moves forward, it meets resistance from the unmoving air and spreads out, getting sucked back into the vortex that forms as the ring continues moving, stabilizing into the donut shape you see, or, more scientifically, a toroid. But this can happen in any fluid, not just air. Underwater, this allows me to create a similar ring of bubbles. You may have even seen this effect from animals, like dolphins. Back to the original demo. The toroidal vortex is so much better at moving through the air than my breath that it's able to carry all of that initial force far greater distances. All right, I've had a lot of fun with toroidal vortices. I guess you could say I like science so much, I put a ring on it. Okay, yeah, that was bad. Anyway, thank you for watching today's episode of Sci Sparks. Be sure to leave a like, and if you want to catch new episodes as soon as they're released, be sure to subscribe. Until next time.